Have you ever wondered how your smartphone or laptop works? A normal computer works with a computer chip. Inside that chip are modules, logic gates, then transistors. A transistor is the most basic part of a computer chip. It's pretty much a tiny electrical switch that either stops or allows electrons to flow. The flow of electrons then creates a bit, which can be 0 off or 1 on. A larger series of bits can create more complex numbers. When multiple transistors are combined, they can create a logic gate, which is still simple. For instance, an OR logic gate gives an output of 1 if any of its inputs are 1. When multiple logic gates are combined, they can finally form a meaningful module for doing basic math operations like addition or multiplication. You can think of a computer as kindergarten students. If each of them does one simple problem and you have enough of them, they can compute almost anything. We're used to this traditional type of computer because we have so many of them around us. But there's a new generation of revolutionary computers being developed called quantum computers, which use atomic and subatomic particles. Quantum computers use qubits, which, like bits, can be set to 0 and 1. But the difference is that qubits are single particles such as photons. A lot of weird things can happen when you start using single particles, and the scientists and engineers who design quantum computers are trying to take advantage of those weird properties. For example, a qubit can be in superposition, which means it can be 0 and 1 at the same time. But when you measure its value, the superposition collapses into 0 or 1. How is that possible? Think of superposition like a coin being flipped. When it's in the air, it's both heads and tails. But when you see it land, you know which one it is. 4 regular bits can be in 16 different combinations, but you can only use one. But if 4 qubits are in superposition, they can be in 16 combinations, and you can use all of them at once. The number of combinations qubits can have grows exponentially. Another property qubits can have is quantum entanglement. It means that 2 particles have such a close connection that when they're in superposition and you measure the value of one, you know the value of the other without even looking. For example, if you measure one qubit that's value is 1, we know that the particle it's entangled with is 0. In the coin flip scenario, if I have 2 coins being flipped that are entangled, and I measure a value of 1 that's 1, I know the other one must be 0. Entanglement can also work the other way, where both particles have the same value. By using superposition and entanglement to their advantage, scientists and engineers can create quantum gates which make up a quantum computer. They're super complicated and there's tons of different types, but to sum them up, they take in particles in superposition, rotate them, and put out particles that are also in superposition that can be used in the computer. The great thing about quantum computers is that they're so fast in searching databases. For example, let's say I'm trying to crack a 4-bit password. On a normal computer, I would have to check every possible combination until I find the right one. But on a quantum computer, I can put in all the answers at once, and my computer tells me wait, it says I'm both right and wrong because I am. I have the right password, but also all the wrong ones. Well, good news for me, there's a thing called a Grover operator, which will take away all the wrong answers and leave me with the right one. Grover operators are also complicated and I won't explain those, but the point is that quantum computers are super efficient in searching databases. This is a big problem for security. On a normal computer, it would take well over your lifetime to encrypt a password by checking every possible combination. On a quantum computer, I can do it in minutes. But don't worry. The good news is that quantum computers are still being developed, so security companies have some time to prepare. Also, quantum computers could completely revolutionize self-driving cars and artificial intelligence. There's so much potential for quantum computers that it's hard to accept. So overall, quantum computers work by cleverly exploiting superposition and entanglement to test all outcomes at once. They'll probably not replace our personal computers, but they could have limitless potential in new inventions to come. Thanks for watching and have a great day.